We will multiply polynomials for a couple days. This is day 1. Like I said, tomorrow we're going to take a break. We're going to take that quiz we were supposed to take before the snow day. And then we should be back on track by Thursday. One of the issues with having a random snow day is it kind of throws all the days off a little bit. So we will have a lesson and we will have homework on Friday. So just prepare yourself. The extra break last week means we got to work a little harder this week, okay? So here is example 1. We are going to simplify. So does anyone remember what to do when you have something like this? Yeah, you distribute. We're kind of looking at it from a different approach. We're thinking of it as a monomial, so one term times a binomial. But it's the same thing we did last semester where we had a number times sum or difference in parentheses. You just multiply each term. Same idea, okay? So we are going to do negative 4 times 2y, which is negative 8y, and negative 4 times negative 3x plus 12x. Good. And I usually put those just to see what I'm doing. If you want to write a step in the middle where you're showing what's multiplying by what, you can. But since we have already distributed, I think you guys probably beyond that. For example 1, that is all, yes. Questions? All right, here is number 2. So once again, if you want to put the little marks, it'll look like this. What is 1/3 times 6x? 2x minus 9. Good. Once again, if you want to write out that step in the middle, go for it. If you can go right from here to here, I'm okay with it. What are your questions? All right, here's number 3. So it's getting a little trickier now because you have to remember those rules for exponents, right? So we are going to do 2a times 5a squared, which would be 10a to the third. Good. And then in the back, we're going to do 2a times negative 8b. Negative 16ab. Good. So there's our final answer. Since when what?
I didn't know you can multiply the a and b, but okay.
You can. You do not have to have like terms for multiplication and division. You do have to have like terms for addition and subtraction. It's like you can't combine the a's and the b's right here, but you can multiply them. Yes, ma'am.
How did we get to 3 again?
We added the a.
Oh, we have a to the first and a to the second. So there's like a 1 here, and they each have their own base of a, so you just add the exponents. We good?
Mm-hmm.
All right, here is number 4. Questions now. You do the same thing, all right? It is this written this way is the same thing as if you write it this way. So if you want to rewrite it, a lot of people just feel a lot more comfortable distributing from the front, even though distributing from the back is the same thing. So we are still just multiplying and multiplying. All right, so when I actually multiply these out, if you want to put the little marks, go for it. You multiply the coefficients, so 6 times 1 is 6. Add the exponents. X to the first, x to the second gives me x to the third. Y to the first, y to the first gives me y to the second. Keep your minus. 6 times 3 is 18. X times, there's not an x here, so you just drop the x. Y times y is y squared. What are your questions? All right, number 5. Okay, so each of those terms is going to be multiplied by that 3/4 x. So we have 8x here, 12 here. Now, on the fractions, I do like to write them out because now I can, like, you know, do the simplifying as I go. So you can cross out, like, the 4 and the 8 and make it a 1 and a 2. 4 and the 12 is a 1 and a 3. Yeah, so in the front, what would you get? 6x squared plus 9x. Good. And then don't forget what you know about like terms. They have different exponents, so you cannot add those. It's not like 15x to the third. You're mixing your rules up, okay? What are your questions? So the 4 and the 8 become a 1 and a 2. And then this 4 and this 12 becomes a 1 and a 3. And then you just multiply. We good? You are still confused?
No.
Oh, okay. I'm sorry. All right, next. Now, how is this one different? Hmm?
Oh, never mind.
How is this one different?
How's this one different? You gotta add you gotta do 2 times, so you get 4.
It's a trinomial.
Yeah, we have a monomial times a trinomial. The other 5 examples were all binomials. Do you think it's any different? No, you're just distributing it now to 3 terms instead of to 2 terms. So you can still write it out if you need to, or you can do it in your head. First term, second term, third term. What is negative 4 times 3? Negative 12. We'll have x to the 4th. In the middle, we have minus 8x to the 3rd. And in the back, plus what? 20x to the 2nd. Good.
That's a lot of work.
That is a lot of work. I am so glad we all got to experience that with you. Questions? No. All right, number 7. Any ideas?
Add a 1 to the 8, so you
Yeah, you can put a 1 here if that helps you. I am sorry, I can't write stuff up there and then have the answer pop up because of the work. So I'm going to show you the answer and then I'm going to go back and do the work. So we are multiplying each term. If you want to just see how they all divide by 3 and kind of do the work as you go, you can cross that out and make it a 9. You cross that one out and make it a 2. Cross that one out and make it a 4. And then just the 3's already taken care of. Do you know what I mean? Just simplify the fractions as you go, then deal with your signs and your x's. If that helps, or you can write it out if not. But remember, this x is in my numerator, so I'm still adding those exponents, okay? And then I'm just basically dividing these each by 3 and then taking care of the negative sign. What are your questions?
Hey,
Who said
All right, here's number 8. So you can see they're getting a little more challenging. Any ideas? Yeah, first we need to distribute in the front. Then what? Distribute in the back and then combine like terms. So you have to distribute twice, then combine things that have the same variable with the same exponent. All right, so after we distribute once, so these, don't forget the negative is going with the 6x. Okay? Any questions where these terms are coming from?
No.
All right, now what are my like terms? I don't know why it's taking away all the excitement. All right, so yes, the x to the thirds go together, right? So it is 8x to the third minus 24x to the third.
Okay.
Great. All right, now I can do my x squareds.
Oh, those cards are.
Do they?
No, they're both negative.
They're both negative, so Adam, keep the negative sign.
24.
Okay, and last.
Negative.
No.
No, negative 28.
Yeah, negative 28.
Good, the signs are different, so we subtract the numbers, keep the sign of the larger. Now, can I combine those all into one big term?
Yeah.
No, you can't.
No, they're still not like terms. They weren't like terms here. They weren't like terms here. They're still not like terms. I don't know why, like, every year there's a couple people that just, like, they don't know when to stop.
No, we're stopped.
I did not name names. I'm just saying. Don't be that person, okay? You cannot add or subtract if they don't have the same exponent. Are we good?
Yeah, we done.
We got one more problem. How come that adding in there? Adding in this?
So previously we had a monomial first, right? So we had one term we needed to distribute. We have two now. So we're going to do it basically the same way. You're just going to distribute twice. I call it double distributing. So we're going to multiply through by the x to everything in parentheses.
Okay.
Then we're going to multiply through by the 4 to everything in parentheses. So you're just distributing twice. Okay? So I'm going to write it out as, I'm going to write like a work step. If you don't want to write this, that's fine. So I'm doing the x times the x. Then I'm going to do the x times the negative 1. Okay? Then I'm going to do the 4 times the x. Then I'm going to do the 4 times the negative 1. Does everyone see what's happening? Okay? X times x is x squared. X times negative 1 is minus x. 4 times x is plus 4x. And in the back I have a minus 4. After you double distribute, the two terms in the middle are usually like terms. Not always, but very common that those are like terms. Negative 1x plus 4x is plus 3x minus 4. What are your questions on the idea of double distributing?
Why don't you like foiling?
That's not.
What do you mean by foiling? Can you explain the definition?
Okay, so some teachers who have not been educated in higher level mathematics, they still call this the FOIL method. FOIL means front terms outside terms, inside terms, last terms. Okay, we don't do that anymore because this does not apply to any situation besides a binomial and a binomial. So when students learn to FOIL, and then I tell them to multiply a binomial and a trinomial, they can't do it. Okay? So that's why FOILing went out of style about 5 years ago. So I shouldn't say people that don't know upper level mathematics, people that just aren't quite as up to date with the new teaching concepts. Okay? Now, I also learned the other day that PEMDAS is no longer called PEMDAS, so who's out of style now? Me.
Please use my dear.
Yeah, Aunt Sally's out.
What?
My daughter said it's called Gemma. So grouping symbols, exponents, multiply and divide, add, subtract.
Nah, I was thinking.
I know, right?
Who is this?
So anyway, FOIL is out, PEMDAS is out, double distributes in, Gemma is in. I don't know. All right, so here's the next one. I'm not really going to write out what I'm multiplying like the first step I wrote out on the last one. I'm just going to do it out loud. So I'm going to do 4x times 3x, which is 12x squared. Then I'm going to do 4x times a negative 2, which is going to be a minus 8x. Okay, so that's the first distribute, but remember this is a double distribute. So now I'm going to do negative 3 times 3x, which is a minus 9x. And a negative 3 times a negative 2, which is a plus 6. All right, like on the last one, we have some like terms in the middle. They're both add the numbers, keep the sign. And I end up with this. Questions? Now, if you are still of the FOIL family, that's fine. You will get the same answer. I'm just not going to say it. All right.
Wait, does that have a star on it? Is this the last question?
I don't know why this one has a star on it. Let's see if something pops up.
Maybe you put the third one so you can tell us it's the last one.
No, I'm not sure what the star is about. It's broken. All right, so what is 5a times 5a? 25a squared. What is 5a times 6?
38.
Plus 30a. 30a. All right, what is negative 1 times 5a?
Negative 5a.
And what is negative 1 times positive 6? Good. All right, same idea. We've got some like terms happening. So 25a squared plus 25a. The signs are different. Subtract the numbers. Keep the sign of the larger. Minus 6. Questions? So yeah, the numbers are the same. The signs are different. That is going to matter. Okay? Because, check out what happens. I have 5x times 5x, which is 25. X to the second. Plus 15x. All right, here's where the magic begins. What's negative 3 times 5x? Minus 15x. And then a minus 9. So these go away, and you have 25x squared minus 9. Now, this right here is called a dots. Dots stands for difference of two squares. So 25 is a perfect square, right? It's 5 times 5.
Yeah.
9 is a perfect square. It's 3 times 3. Difference means a minus. So we'll come back to this in a couple weeks, but just kind of put this in the back of your memory, okay? If the signs are different and all the numbers are the same, the first two are the same, the last two are the same, one's a plus, one's a minus, the middle terms are going to go away, and we're going to end up with a difference of 2 squares. All right, questions? All right, how will I start this one? 4x squared plus 10x plus 10x again plus 25. Very good. Questions? All right. Now, this one and this one are very similar. Do you see how these are the same?
Yeah.
But they were already written out?
Yeah.
That's what I need to do on this one. So they're the same, but before I can double distribute, I need to write it out how many times? Twice, okay? So this is the same thing as this. It is not the same thing as that, like we've been doing. That's what you do if what's in parentheses is a monomial. We cannot do that. It is not allowed. This just means I have both of these terms multiplied twice. So write it out twice and double distribute. You cannot take an exponent across an addition or subtraction sign. This one should probably get a star. Okay? If you just square the 3a and the 2, you will end up missing a whole term, and that's going to be a big problem, okay? When we double distribute, we end up with the middle term that you would not get if you did it wrong. So careful on this one. 3a times 3a is what? 9a squared. 3a times 2 is? 6a. Now we go in the middle. 2 times 3a is 6a. 2 times 2 is 4. This is 9a squared plus 12a plus 4. Four. All right, are we good?
We gotta do this.
Uh-huh. All right. Is this already written in your notes or you got to add it? It's already there, so we're good to go? All right, I'm going to start by getting rid of all my parentheses. So I'm going to distribute. X times x is x squared. X times a minus 5 or a negative 5 is a minus 5x. All right. Now, the 7x is fine. The 3 is fine, but I can distribute this guy. So this is going to be plus 8x plus x squared. Now, eventually we will learn how to solve these where your x squareds don't go away. But for this first time you're seeing it, when you don't go to combine your x squareds, do you see how they're going to cross out? Okay? That's great. That's going to make things a whole lot easier. All right? At the same time we're doing that, we can combine like terms. We should probably, let's combine like terms first. I'm getting way ahead of myself. If you did it, it's fine. All right, I'm going to combine like terms. So I have x squared minus 3x minus 1. On the right, I'm going to write the x squared in the front. I have 15x. I have plus 3. Now, I want to get all my x squareds and all my x's to the same side of the equal sign.
Okay.
Do you want to get them all over to the right side or to the left side? It doesn't matter. To the right. Okay. How will I move an x squared to the right?
Subtract the x squared to the left. I mean, from the left.
Okay. Now, this is what I was getting a little too excited about. My apologies. Do you see how those are just gone? That's great. Eventually, I will teach you how to solve these where they don't cross out. But for tonight's homework, they should all just cross out, okay? You should end up with the same coefficient. And when you go to combine them, they should go away. But I can still get the x's to the same side. Shh. So I need to add 3x. So I have a -1 equals, the x squareds are gone. What's 15x plus 3x? 18x and plus 3. Yep, now you just solve it like, first chapter way back in the day sort of a problem.
Alright. Well, I know.
Shh. All right, we need to reduce this fraction. They're both divisible by 2, so this is -2/9.
X to this.
Yeah, so I'm going to distribute on both sides. So x times x, x to the second, x times 3, plus 3x, plus 4x, plus 12. Good, you guys are getting quick at that. All right, on the right side of the equal sign, I have plus 5x, plus 1x, plus 5. All right, combine your like terms. The order looks fine on this one. Usually we go from biggest exponent to smallest exponent if it's not already like that. This one looks good to go. So I have x squared plus 7x plus 12 equals x squared plus 6x plus 5. Do you want to get everything to the right side or to the left side? All right, and by everything I mean all the x's. So when I subtract the x squared, luckily what happens? Those are gone, all right? I can also subtract the 6x. What's 7x minus 6x? 1x, even better. All right, what's the final step? Very good.
Today we learned
Oh, dang it.
multiplying polynomial numbers. Polynomial numbers.
Today we learned to multiply polynomials. Perfect. All right, so you have 2 giant tasks tonight. Do your homework for this lesson. Okay? I am actually not going to check that though until Thursday. Tomorrow is just the quiz. Tomorrow's kind of like a separate day. Okay? So you'll come in, you'll take the quiz, you'll do the day 9 homework. I'll check day 9. I will check day 10 all on Thursday. That's your first task, is to get that day 10 done. Your second task is to get, we did 2 days of review last week. We talked about the day 8. There was also a day 7. Get them out. Take some time. Look over them. Study for that quiz. Okay?